Till now we have seen gaseous air pollutants, oxide of sulfur, oxide of nitrogen, oxide of carbon, and how they are going to adversely affect on human life and the plant life. Now let us go for the second type of pollutant, that is particulate pollutant, which affect the tropospheric level. So particulate pollutants are, they can be divided into two types: viable particulate pollutants and non-viable particulate pollutants. Here we are going to concentrate on the non-viable particulate pollutants. So these non-viable particulate pollutants are smoke. We can see in the picture how smoke is generated. Generally due to the fire, smoke is generated. This is dust in the sandy areas. Due to the blowing of winds, dust is generated, which goes to the atmosphere and remains there. That small particles of the dust are going to remain in the atmosphere only, and they can be exhaled through us. This is mist, you can see shown in the picture, and these are the fumes coming out from the chimneys of our factories. So these four are the non-viable particulate pollutants. Now these pollutants, what they are going to cause? Yes, if we are going to inhale them, if the size particle is 5 micron, they can be inhaled by us. They will remain there inside the nose and they are going to cause us the problems. They can get combined with our red blood cells. You can see that lead from the automobiles can affect our red blood corpuscles. So leaded petroleum products are not used. If 10 micron particles can go to the lungs and they can have adverse effects on our lungs. So let's study when two type of things are going to come together. We can see the word, that is smog, which is formed by the combination of two words, that is smoke plus fog, called as smog. There will be two types of smog. One is classical smog, another one is photochemical smog. This topic from this chapter is very important. Many questions are asked depend on this topic. So classical smog and photochemical smog. Let's see the difference between these two. Classical smog, it is generally formed during cool humid climate. It consists of smoke, fog and sulfur dioxide. This is very important, and we already seen that when sulfur dioxide reacts with oxygen, it is going to get converted into SO3. So here this sulfur dioxide is having reducing character. So classical smog is reducing smog. Let's go for the photochemical smog now. It is generally formed at warm temperature, dry day and sunny climate. So we can say that it is formed in the early morning. Classical smog gets produced in the early morning when smoke, fog and SO2 comes together, and photochemical smog is generally formed during the daytime when it is going to be sunny. How it is formed? It is formed by unsaturated hydrocarbons, burning of unsaturated hydrocarbons, sunlight and nitrogen oxide. As oxides of nitrogen are oxidizing, photochemical smog is going to be oxidizing smog. So 2 points are very important. Classical smog have the gas SO2, photochemical smog have the gas NO2. Classical smog is formed in the early morning and photochemical smog is formed during the daytime on the sunny day. Classical smog is reducing smog and photochemical smog is oxidizing smog. The reason behind that, which gas is present in that smog. Yes, we can see the picture of the London, the famous one, London smog occurred in 1952, the December month. Why that London smog for? Because of smoke, fog and sulfur dioxide present in the air. Yes, this is photochemical smog. Now during the photochemical smog, what happens? What reactions occur in the photochemical smog? We have seen that classical smog contains SO2 and photochemical smog contains oxides of nitrogen. So in photochemical smog we are going to see some reactions, that is NO, nitric oxide, in the presence of sunlight will react with oxygen and it will form nitrogen dioxide. This nitrogen dioxide again by using sunlight will get converted into nitric oxide and this oxygen. Now we can see that there is only one atom of oxygen. It is not in the form of dioxygen. Dioxygen is stable one, but this single oxygen, this mono oxygen is highly reactive, and this oxygen, highly reactive oxygen, is going to react with another dioxygen molecule to form the ozone, O3. The ozone is formed. Now this ozone reacts with nitric oxide again, and it will form NO2, and that NO2, yes, is the hazardous gas itself. Unburned hydrocarbons can react with this ozone, to form CH2O. It is nothing but the C double bond OHH. What it is? It is called as formaldehyde. So in photochemical smog, by all the chain reaction, what is generated? In photochemical smog, formaldehyde generated. Now by using this, what can be created? This is acrolein, and that is PAN, that is polyacrylonitrile polymer. Photochemical smog, yes, we can have lot of adverse effects. We can see through the picture: irritation to the eyes, headache, then throat problems, then the rubber of the tire, it is going to affect on the plants also, and the metals we are using are also affected by the photochemical smog. How to how to cross over this photochemical fog? How to come over these adverse effects of the photochemical smog? How to control the photochemical smog? We can use catalytic converters to our automobiles. We can have the plantation of these plants, Pinus and Juniperus, then Quercus, Pyrus and Vitis. These can control the photochemical smog.